Federal Drive is presented by GEHA, Government Employees Health Association, proudly providing health and dental benefits to federal employees and their families. Visit GEHA.com.
The Army is taking the next step in its ambitions to start using small nuclear reactors to power critical infrastructure on at least some of its bases. This week, the service started the solicitation process for its Janus program via the Defense Innovation Unit. And assuming the technology works out the way the Army thinks it will, we now also know some of the first bases that are most likely to benefit from it. Details here from Federal News Network's Jared Serbu.
Officials want to test the feasibility of using the microreactor power plants to deal with what they say are several problems: frequent electrical outages, increasing power demands, and a limited menu of backup generation alternatives. The Army says it's convinced the commercial technology behind the latest generation of reactors is viable. The big question now is cost. So this week, through the Defense Innovation Unit's Commercial Solutions opening, the Army released a solicitation asking vendors to propose microreactor designs that the service will test on 9 separate bases between now and 2030. Dr. Jeff Waxman is the Principal Deputy Assistant Secretary of the Army for Installations, Energy, and Environment.
What resilience means to us is that we have power no matter what, 24/7. And right now on Army installations, as well as every other service, that resiliency is provided 100% by fossil fuels. Anyone who's seen big solar panel arrays on motor installations knows that the moment that you have a black start exercise, the grid goes down, those are immediately cut off. They do not provide power. So the resiliency is fossil fuels. You have a certain number of days of backup power, but that is a huge vulnerability, particularly if you start to look at like Arctic locations or Pacific locations. So the only technologies that we have now that could be possibly applied to Arctic or Pacific locations to provide 24/7 power for a long length of time is nuclear power. It's the only option that we have right now.
Waxman says the Army is confident the commercial nuclear industry can support the service's ambitions and meet a Trump administration goal to have an Army-regulated nuclear reactor up and running on a domestic military base by 2028. For now, the biggest question is cost, and for the time being, officials aren't even sure exactly how to define the cost-effectiveness of a nuclear option.
That's a hard question, right? Because that's going to eventually be an Army senior leader discussion. And the question is how much are we willing to pay for resiliency? And so I think that's still an open question, and that's going to be part of what we're going to try to figure out here. I don't think we need to meet absolute parity with fossil fuels, but I think we've got to be reasonably close. But if you look at, we're used to, where we sit here, paying, 10, 12 cents a kilowatt hour for electricity. But if you just go out to Hawaii or Alaska, they're already paying upwards of 40 cents a kilowatt hour. So these reactors don't need to be 10 or 12 cents a kilowatt hour to be parity. They need to be something like 40 or 50 cents a kilowatt hour. I think there's going to be a big market for them. But exactly what that number is, that's part of what we need to figure out over the next few years.
But Waxman says there are other reasons for the Army to get involved now, beyond just determining the cost-effectiveness of commercial nuclear technologies. He says the Army also wants to influence the development of the U.S. nuclear industry, and not necessarily with funding. There's already plenty of that in private markets, with several companies having raised hundreds of millions of dollars to develop their reactor designs. He says the nuclear industry is already very hot.
Now is the perfect time for the government to get involved because there's multiple companies, nuclear startups that now have gone public and have market caps of over $1 billion. And the problem is that you have like a dozen different companies with a dozen different supply chains, and there's no way that that's going to actually work, right? We're going to have to neck this down. And for a comparison, in aviation, Boeing and Airbus are vehement enemies, but they use a lot of the same supply chain because having two fully parallel supply chains doesn't make sense for airplanes. And so that's part of the role that we're going to play here as these companies are developing their designs, is trying to help squeeze them into similar supply chains. So for instance, if a company wants to use a particular flavor of graphite or stainless steel in their core, we can say, well, that's great, but that material hasn't been qualified. We don't have a qualified supplier. If you change to this other flavor, you might have a 0.8% reduction in performance, but we have a qualified supplier and that material is qualified. Let's try to move everyone to the same stainless steel alloy. And that will not only give more options to these companies, but it also encourages these suppliers to actually expand and make assembly line components. Because right now, nuclear reactor components tend to be one-off, custom, handmade components.
As part of the partnership with DIU, the Army plans to use an iterative prototyping process via other transaction agreements to test the reactor designs on 9 bases, which were also announced this week. They are Fort Benning, Fort Bragg, Fort Campbell, Fort Drum, Fort Hood, Fort Wainwright, Holston Army Ammunition Plant, Joint Base Lewis McChord, and Redstone Arsenal. At each of those sites, the companies selected are expected to start by building a first-of-a-kind reactor, then use lessons learned to improve on that commercial design with a second-of-a-kind. Waxman says there's a precedent for that kind of government involvement, both in terms of technology and in workforce development. The Army is trying to emulate the model NASA used to spur development of the space industry through its Commercial Orbital Transportation Services program.
When NASA wanted to start commercial rocketry, they started the COTS competition, Commercial Orbital Transportation System, and that was the competition that basically created SpaceX. SpaceX took an industry where, the A students in engineering didn't want to go into rockets. It wasn't cool. And SpaceX made it cool again. And suddenly you had all the really smart engineers on campus wanted to get into space and rocketry. And so there's a feeling of, well, nuclear needs its SpaceX, right? And so there are these, innovative, exciting startups. And so we're hoping to cultivate them in the same way that NASA cultivated SpaceX and make nuclear sexy again. And encourage more of the top young engineering talent to want to go in the field. Because right now there's a tremendous shortage.
Waxman says another reason the Army is attracted to the current generation of small nuclear technologies is the sense that they're inherently safe and don't come with the complications involved in more traditional utility-scale nuclear reactors.
First, I'll remind people that the worst nuclear accident in the history of U.S. commercial was 3 Mile Island, in which no radiation was released and no harm was done to anybody, which I believe is quite a selling point compared to every other form of energy. But that said, the fundamental difference between these new reactors and those are what's called Generation 2 reactors, 1960s design, is passive safety. So the idea of traditional reactors is that you have levels of redundancy of safety. So you say, okay, if this part breaks, here's the backup. And if the backup breaks, here's the backup to the backup. But at some point, some positive action may need to be taken by somebody. And if your system breaks entirely, it's possible to melt down and damage the fuel. The premise of a passively safe reactor is that if the reactor breaks and all the control rods are in the wrong place and all the operators are pressing the wrong buttons, there's still no way to get the fuel to a temperature that it can melt. And so that's why we use the phrase passive safety. There's no active action that's necessary to prevent damage to the fuel. And so that's typically what is referred to in Generation 4 nuclear reactors, which is what we're trying to build.
Jared Serbu, Federal News Radio, part of the Federal News Network.
You can find Jared's story at federalnewsnetwork.com.